Okay, so this is chapter 9, section 3, part 3, and you just did parts 1 and 2 recently, and I know that it was a lot of information. Then we're going to take a little bit of a step back. We're going to do some more general math with well, actually it's not all on the unit circle, but just with trigonometry. We're going to refresh our memory on sines, cosines, and tangents. Cosecants, secants, and cotangents. The last three, cosecant, secant, cotan, might actually be not unfamiliar to some of you, and that's okay. We're going to learn about them in this video, and we're going to stay extremely organized so that we don't get confused. Trigonometry is a completely new language of mathematics. It is very easy to get lost in it, very easy to get confused, very easy to mistranslate. So let us do our best. You're going to have to start out on page 478. You are going to need to copy down the core concept at the top of page 478 and the top of page 479. I am not doing that for you in this video. I am going to use those core concepts, however. If you need to pause here, copy it down from your textbook, go for it. If you need to open the Big Ideas website and copy it down from the dynamic ebook, you should do that now. I'm going to switch to my video. To my document cam, I mean. And so here's the core concepts I wanted you to copy down. We're on page 479. You should be unpausing at this moment. And we're going to do number 1. So the directions are very important. It says evaluate the 6 trig functions of theta. All right. So that means I'm going to copy it down because drawing is everything. And also knowing what theta they're talking about is extremely important. So here we have our x-axis, our y-axis. This should be familiar by now. We have our circle, and our thetas always start at the positive x-axis, as we've talked about before, I hope. So it looks like they're giving us an angle that goes down into quadrant 4, and it goes this way, and it goes through the circle at a point 3, -3. Now, they want us to evaluate the 6 trig functions, which means the first thing we're going to do is we're going to create this chart, sine, cosine, tan. We're going to leave a space for our answer. Cosecant, secant, and cotan. Remember, CSC stands for cosecant, SEC stands for secant, and COT stands for cotan. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tan and cotan are reciprocals. Now, you're looking at the core concept on page 478 to follow along with me. So the sine, they say, is y over the radius. So I guess we actually have to figure out what is the radius in this case, because this is clearly not on the unit circle. Both these numbers are bigger than 3 or smaller than, bigger than 1 or smaller than -1. So if the x value is 3, that means I have a leg of a right triangle that goes out here. The y value is -3. So I have a leg of the right triangle that goes here. And using the Pythagorean Theorem, 3 squared plus -3 squared equals, I'm not going to write c squared because this is trigonometry. I'm going to write r squared because we're looking for the radius. Remember, look at the core concept. Sine is y over r, cosine is x over r. R is what I need. I have x, I have y. All right, well, 3 squared is 9. And oh, guess what? -3 squared is also 9. 9 plus 9 is 18. And the square root of 18, well, let's see. What's the biggest perfect square I can take out of 18? It's 9. What's the square root of 9? It's 3. And 9 times what is 18? 3 rad 2. And of course, our radius is going to be positive. This is a length. Our radius is always going to be positive. Okay, so now I know my radius is 3 rad 2. So just to help you out, I have an x, I have a y, and I have an r. So my sine is going to be -3 over, I don't want to do the math here because I can already tell that it's going to take some work. So let's start working down here. Sine is y over r. I have -3 over 3 rad 2. And I can simplify. So we have 3 and 3 cancels out to 1 and 1. So it looks like I start to have -1 over rad 2. And I'll do the math here for you, but you're going to have to start doing this in your head. We need to rationalize the denominator. -1 times rad 2 is negative rad 2. Rad 2 times rad 2 is 2. So my sine is negative rad 2 over 2. Okay, let's see what happens with cosine. Cosine is x over r. So I have the cosine of theta is 3 over 3 rad 2. Right, I take my x from the chordate pair, I figured out my radius. Oh, well, look, 1 over 1. So I have 1 over rad 2. Now wait, -1 over rad 2 became negative rad 2 over 2. So +1 over rad 2 is going to become positive rad 2 over 2. All right, go back here, look at the math, do it down here if you need to. But again, I need you to start doing this in your head. Well, rather, you are going to want to start doing this in your head. Okay, tan. Tan is y over x. So wait, -3 over 3 is just -1. Okay, now let's try to be organized because we can get really, really lost. The cosecant is the reciprocal of sine. Now wait, if I take this answer that I have here for sine and I take the reciprocal, I get 2 over negative rad 2. Now then I have to do some math, correct? And I'm going to get 2 rad 2 over -2. The 2's simplify to 1 and -1, and we put the negative on top. We're going to get negative rad 2. But there's an easier, oh, I apologize. You could not see that. I took the reciprocal 2 over negative rad 2, and I multiplied by rad 2 over rad 2, and I simplified it, and I moved the negative up top. I got negative rad 2. Okay, but there's an easier way to do it. Go back to our sine work. What was the step before rationalizing the denominator? It was this step right here. And what if I take the reciprocal of -1 over rad 2? Aren't I going to get negative rad 2? So it's important to, when you do your sines and cosines, to at least keep an eye on what the simplified fraction is before you take the reciprocal. So the simplified fraction for my cosine before I took the reciprocal is 1 over rad 2. And guess what? If I could just easily take the reciprocal of 1 over rad 2, it's rad 2 over 1. And likewise, tangents are usually nicer. -1, the reciprocal of -1 is -1. Okay, I know that was a lot. If you have any questions, table it for later. Let's see if we can work out some more with number 2, okay? It was a lot of math doing the 6 trig functions and a lot of confusing steps where the details are important. All right, I am going to try to squeeze number 2 at the bottom of this page, and that, of course, might be my famous last words, but I have a feeling that we're not going to get radicals, because if you're looking at it already, you're looking at number 2 already, you're going to notice that it's a very special right triangle. So we want to do this angle here. Now, the nice thing about trigonometry is when you're dealing with this beautiful obtuse angle and it's in quadrant 2, you actually can just deal with the x-intercepts. Sorry, wow, that was really stupid. You can deal with the point, -8 and 15. So we're going this way 8, we're going up 15. And so even though we're talking about this giant angle here, we're using this triangle right here that has a different angle. It just works out because math makes sense, and you're going to have to trust me on this one until you get a little further in trigonometry, probably next year. All right, well, you've probably noticed that this is an 8, 15, and 17 right triangle. If you don't believe me, go ahead and do the Pythagorean Theorem. Negative 8 squared plus 15 squared, take the square root of it, you're going to get 17. But I told you to memorize your perfect triangles. 8, 15, 17 is one of them. Okay, so let's start filling out. I know my x, I know my y, and I know my r. So if it asks me for the 6 trig functions, I am always going to make the same list. Sine, cosine, tan, leave a space, cosecant, secant, and you should probably want to say these with me, cotan, because 1, you need to practice to say them. 2, there's a pattern in how to know which one of these goes as a reciprocal with these sines and cosines, and the more you say it, the more you're going to see it. All right, so sine is y over r. I'm really having trouble speaking in this video. Y over r. Cosine, x over r. Tangent, y over x. Now, wait a second. You're not writing the negative in the denominator. You're putting it up top or out front. So negative 15 over 8. Let's take some reciprocals. 17 over 15. 17 over negative 8. Nope. Negative 17 over positive 8. And again, we're not writing the negative in the denominator. We're writing it on top or out front. And there you go. So that's, how to do right angle trigonometry, evaluate the 6 trig functions. It's a little nicer to see without radicals. It helps us kind of take a breather and just look to see what we're doing. We're identifying the radius. Use the Pythagorean theorem if you need to. And then we are using our rules from the core concept on page 478. This column and this column, they are reciprocals of each other, and we're just going to be careful with our signs. All right, I'm going to turn the page. We're going to do number 3. We're going to do number 4, and that's enough for this video. Okay, so, number 3, another special right triangle, a Pythagorean triple. Y-axis, x-axis, that's what makes it trigonometry. And we have an angle right here, but it's not the easy way, it's the counterclockwise way of getting there. Theta, and this point is -5, -12. It's in quadrant 3. And if we look at it as a right triangle, the x is -5, the y is -12. That means that the radius is 13. It's a 5, 12, 13. Again, if you don't know because you don't have it memorized, then use the Pythagorean formula. It tells us to evaluate the 6 trig functions. We always make the same chart so that we stay organized. Okay, so sine is y over r. Cosine is x over r. Tangent is y over x, but a negative divided by a negative is a positive. Let's take the reciprocal, remembering that our negatives go on top or in front. So r over x for secant. Cotan, don't need to worry about signs. It's positive 5 over 12. And there we go. That is our, I apologize again. That is our, those are our 6 trig functions for this theta right here. Even though we're making a triangle over here, there's the right angle. This is kind of like the little angle we're talking about, but the math works out. Okay, a little bit more abstract. Use the unit circle to evaluate the 6 trig functions of 180 degrees. All right, well, let us draw out what 180 degrees is, even though the book doesn't do it for us in this case. So 180 degrees right here. We are talking about a beautiful straight line. Theta is 180 degrees. All right, well, let's write our chart down, our table. All right, and now we just have to figure out, but wait, why don't you go back to your unit circle? What is the x and the y out here? So remember the unit circle, and this is not a beautiful circle. I apologize for my messiness, figure not drawn to scale. Not an artist. The unit circle has a radius of 1. So we went this way by 1. So our x is -1, and we're not up or down anything, -1, 0. What is our radius? It's 1. What's our sine? 0 over 1. What's our cosine? -1 over 1. What's our tangent? 0 over -1. Okay, now, what is our cosecant? Well, I could ask you what the reciprocal is of 0, but that might be a ridiculous question you've never heard before. If it is something you've heard before, then I think you know the answer. However, let's go back to our chart on page 478. The radius 1 over y, r over y, 1 over 0. Now, is that a fraction you can have? Of course not. So the answer is doesn't exist. We can do a circle with a line through it. However, our secant, what is the reciprocal of -1? It's -1. And then, of course, what do you think the reciprocal of 0 is going to be? The reciprocal of 0 does not exist. So here are our 6 trig functions for 180 degrees. The sine is 0, the cosine is -1, the tan is 0. The reciprocal of 0 does not exist. The reciprocal of -1 is -1, and the reciprocal of 0 does not exist. By the way, just for future reference, the reciprocal of does not exist is 0. That's going to come in handy for a few problems, okay? All right, that is enough for now. It takes some practice. It takes some time to just let it sink in. So give yourself the chance to try it out, make some mistakes, and we will reconvene.